వెల్కమ్ బ్యాక్ టు శ్రీకర్ ట్యూషన్స్. శ్రీకర్ ట్యూషన్స్లో మనం ఈరోజు సెకండ్ ఇయర్ ఫిజిక్స్ లాంగ్ క్వశ్చన్స్ కిర్కాఫ్ లాస్ గురించి నేర్చుకుందాం. కిర్కాఫ్ లాస్ ఇది కూడా వన్ ఆఫ్ ద వెరీ ఇంపార్టెంట్ క్వశ్చన్ ఫర్ యువర్ ఎగ్జామినేషన్. ఆల్రెడీ యాజ్ ఐ టోల్డ్ యూ 3 long questions are there. So in the 3 long questions, one of the important long question is Kirchoff laws. So now let us see the first law of Kirchoff. Kirchoff first law. So Kirchoff first law is tells us about the sum of current flows through a junction. The what is that? The flowing into the junction should be equal to the moving away from the junction. For example, this is a point. So let us see here what is the meaning of junction. So here some current connections are moving towards the junction. Some current connections are moving away from the junction. For example, current, as we know, current is denoted by I. Okay, so this is I1, I2, I3, I4, I5. Okay, so these are the current connections. So as per the first law of Kirchoff, so what he is telling, the current moving which is towards the junction, that should be equal to moving away from the junction. See here, see the arrow marks. So it is indicated this flow is moving toward the junction and this flow is moving away from the junction. Okay, so this is tells us about Kirchoff first law. As per that Kirchoff first law, what is that? As per the law, for example, I1 and I2 are moving towards, means I1 plus I2 is equal to I3 plus I4 plus I5. This is first law of Kirchoff. Kirchoff first law. Okay, let us see here clearly. I hope you understand. Let us see. So first law, just now I explained to you. First law in the sense, the current which is moving towards the junction should be equal to moving away from the junction. Okay, here is the junction. Okay, sum, and one more definition also here about first law, that algebraic sum of current flow is called also, what is that? Kirchoff second. Let us see. So this is I1, I2, I3, I4, I5. Okay, this is junction, this is the junction, and these are the current flows. As per the Kirchoff law, so sum of currents which is moving towards the junction. So what are they? 1, 2, 3. These 3 are moving towards the junction. I1 plus I2 plus I3 is equal to, moving away from the junctions are I4 plus I5. This is Kirchoff first law. When you transfer these I4 and I5 to here, it become I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. This is equation number 1. So we can take this, the algebraic sum of current flows. Algebraic sum means this is the combination of plus and minus, that should be equal to 0. These equations are called algebraic equations. Okay, the algebraic sum of current flows through a junction is called Kirchoff first law. This is first law. Now second law. Second law tells us about that voltage. So here voltage means the enclosed circuit algebraic sum of potential differences. So potential differences should be equal to 0. That is second law of Kirchoff. So what is that? The enclosed circuits, the sum of potential differences should be equal to 0. That is second law. This is first law. Second law, as per second law, sum of potential difference should be equal to 0. Sum means sigma. We can take sum means sigma. Sigma V equal to 0. So that is potential differences. And V means as per the Ohm's law. What is the formula for V? As per the Ohm's law, V equal to IR. Since substitute here. Okay. So when we substitute here, V1 equal to IR1 plus V2 equal to IR2, V3 equal to IR3. Okay. So here V is equal to IR1, IR as per the Ohm's law, we can write V equal to IR. Now let us see. E minus IR1, IR2 minus IR3 is equal to 0. Okay. So E means energy. Okay. So E minus IR1, IR2, IR3. IR1 means V, sigma V. So this is algebraic sum. Okay. When we transfer here E, it become IR1 plus IR2 plus IR3. When you took I common, R1 plus R2 plus R3. Okay. So therefore I is equal to E by R1 plus R2 plus R3. This is I equal to formula. Okay. Now this is about Kirchoff first law and Kirchoff second law. Okay. I hope you understand. Now let us see here. Okay. So as I told you, V sigma V equal to, second law is Kirchoff second law, sigma V equal to 0 means potential difference. The algebraic sum of potential difference should be equal to 0. But here we are writing as per V, as per Ohm's law, V is nothing but IR. Meeru 10th class lo nerchukuntaru, V equal to IR. So Ohm's law. So here I substituted V place lo IR. Okay. Now let us see here Wheatstone bridge. Wheatstone bridge. Let us see. This is the very important. Okay. Yeah. So I hope you understand Kirchoff first and second law. Now let us apply these Kirchoff first and second laws on the Wheatstone bridge. Okay. Let us see. This is a Wheatstone bridge. Okay. See here. Here in this Wheatstone bridge, one battery is here. These are all connections, current connections. Okay. So this symbol, I hope you know this symbol is resistor. Okay. So this symbol is resistor symbol. So here this in this connection, so 4 connections are here. A to B one connection, B to C one connection, C to D one connection, again D to A one more connection. Total 4 connections are here. Okay. So here every connection has one resistor. Okay. In first connection the resistor is R1. In second connection the resistor is R2. In third connection the resistor is R3. And fourth connection the resistors are R4. And how much current is here? Current is passing or not? How can we detect? So we have to know by using of galvanometer. Okay. When the galvanometer needle deflected, by that we can conclude that some amount of current is passing through this circuit. That's why here we arranged galvanometer. Okay. So and here power supply. Power supply here we are taking as power supply as battery. Battery is here power supply. Okay. So this is Wheatstone bridge. Now here we have to apply these first law, second law in this Wheatstone bridge. Okay. In the first circuit, in the first connection, the current amount of current is I1. In the second connection, current of amount is I2. Here I3 and I4. And observe the figure. Here A to B, the current is moving towards. Okay. And B to C current is moving like this. Okay, and here these two are moving in one direction, and A to D and D to C, these two are moving another direction, opposite direction. See here, observe the arrow marks. Okay, so by observing the arrow marks we can conclude that the directions of current supply. Okay, now let us see. Here in the galvanometer also, when power is supplying here, then only it can deflect it. That's why here. Now apply the Kirchoff laws. First law. First law means, see here, I1 equal to Ig plus I3. Okay, these two are same directions. So about that here I am writing. So I1 equal to, at C, I1 equal to I3 plus Ig. This is equation number 1. Next, applying second law of Kirchoff. So applying second law on the closed mesh. Apply second law on closed mesh. A, C, B, A. A, C, B, A means this half triangle. It seems like triangle. So A, C, D, A. So here when we apply Kirchoff second law, that is minus I1P minus Ig G plus I2 R is equal to 0. So I2 R, because these two are in same directions, that's why here same symbol, and I2 is opposite direction, so that's why other symbol. Okay, so now let us, this is equation number 2. Next, closed mesh CB in CBDC. In CBDC, minus I3 Q plus I4S plus Ig G is equal to 0. Okay, so this is equation 3. 3 equations. Fourth equation. At junction D here, at junction C calculated, at junction D, at junction D, I2, I4 equal to I2 plus Ig, equation number 4. Now here we apply first law and second law on the Wheatstone bridge. Okay. Now let us see, when we compare these 4 equations, if the in the galvanometer, in the Wheatstone bridge, in the galvanometer, if it is not showing any readings, means galvanometer Ig value is 0. When Ig value is 0, when Ig value 0, Ig value becomes 0. If no current is passing through the galvanometer, then Ig value is 0. So whenever Ig value is 0, substitute Ig values in all the equations. It becomes I1 equal to I3. Here I1P equal to I2R, means I2R equal to I1P. Next here I4S equal to IQ3, because Ig value is 0. Here I4 equal to I2. Okay, so when we substitute Ig value, Ig equal to 0 in all these equations, we will get, here I am writing directly. Okay, I1 equal to I3 and I2 equal to I4. So therefore, next I1 P equal to I2R, and this is equation number 5, and I3Q equal to I4S, equation number 6. Okay, but we know I1 means I3 and I2 means I4. Can I write like this? I1 means I3P equal to I2R, and so I4 means I2, I3Q equal to I2S. Okay, when we compare all these equations, finally we will get the answer. I1P, నేను ఇంతకుముందు రాసిన ఈక్వేషన్ మీరు రాసుకోండి, ప్లేస్ లేక అది రబ్ చేశాను. I3P, sorry, I3Q equal to I2R by I4S. I1 means we can write I3 means I3P by I3Q. I2 means we can write I4R by I4S. I3, I4 will be cancelled. Therefore, final answer is P by Q is equal to R by S. This is the final answer, Wheatstone bridge answer. Okay, this is Wheatstone bridge. Once again I am repeating you. Okay, so Kirchoff first law. Kirchoff first law means when the current flows through a junction, the current which is moving towards the junction should be equal to moving away from the junction. Okay, this is that. So we can write this equation as algebraic sum of current. Okay, that is equation 1. Next, second law. Second law tells us about when the current passing through the junction, the voltage, the sum of voltage should be equal to 0. That is sigma V equal to, sum means sigma V equal to 0. But we know V is nothing but, as per Ohm's law, V equal to IR. మీకు ఇది బుక్స్లో ఇవ్వరు, చూసుకోండి. V is equal to IR. Substitute V equal to IR formula. So here I minus R1, R2, R3. So whenever we transfer all this, we get I value. This is Kirchoff first law, second. Now let us see here Wheatstone bridge. Wheatstone bridge is a junction. Okay, and here this is a power supply, battery behave like a power supply, and how much means current is passing or not, how can we detect? By using of galvanometer. Okay, galvanometer tells us if the galvanometer needle deflected, then the current will pass through the junction. Okay, so here by seeing this, now apply first law at C junction and at D junction. Okay, here. Okay, so D junctions, so this is moving away, this is moving towards the D junction. These AD and this IG are moving towards the D junction, and this I4 is moving away from the D junction. In the same way at C junction, so this second one, sorry, I3 is moving. Okay, and IG also moving. Okay, this is away from the junction, reverse. So when we applied first law in two junctions, remaining junctions when we applied second law, so we get like this. Okay, if galvanometer reading is not seeing anything, means current is not passing there, so that is IG value is 0. So when IG value is 0, when substitute IG values in all the equations, you will get like this. I1 equal to I3, I2 equal to I4 and like this. Okay. So when we compare, when it is cancelled, you will get P by Q equal to R by S. This is Kirchoff first law, second law applied on the Wheatstone bridge. I hope children, if you understand, if you like this, like, share, subscribe Sri Tuitions YouTube channel.